Everyone. Today's lesson is where we'll be starting to talk about something called logarithms. So there is a definition written up there for logarithm for you. It's kind of just a verbal description of how you evaluate what's called a logarithm. I will be splitting this lesson into a couple of different videos so that you don't have to tackle it all at once because there's some different sections here that I want us to kind of explore. So take a second, get that definition written down, and then we'll talk about what the heck is this thing called a logarithm. So a logarithm, we usually abbreviate just by using the word log, okay? And what logs are all about is inverting an exponential function, okay? Their main purpose is to serve as the inverse of an exponential function. So we're going to be going back and forth between what's called logarithmic form and exponential form quite a bit because a logarithm is really just a rearranged version of an exponential equation, okay? So if we have an equation that looks like this, y equals b to the power of x, let's say, that's an exponential equation. If I want to write that in logarithmic form, I write log, and then I'm going to use a base of b, which is the base in the exponential function over here as well. So I'm going to put a little subscript b here under the log. And then you go log base b of this number, the answer from the exponential function. And then this is the key part to a log, is that the answer to a log is always the exponent itself, okay? So if I took this thing and wanted to rewrite it in logarithmic form, this is what it would look like. Log base b of y equals x. So I want you to kind of see how these two things are related to one another. That if I was given this exponential form, and really probably easier to think about this as like b to the x equals y instead of y equals b to the x, it doesn't really matter. But for what I'm about to show you, it'll make more sense if we write it this way. When I go to write that in log form, I start here and I go log base b of y equals x. See that kind of circular motion there? Log base b of y equals x. Log base b of y equals x. So I'm kind of moving in this direction and always ending at the exponent because that's the important part of a logarithm, is that a logarithm is really equal to an exponent. If I wanted to go back the other way, so if I was given something that looked like this and I wanted to rewrite it as an exponent, which we're going to be doing quite a bit of, I start down here with the base and I go b to the power of x equals y. So it's always kind of that same motion, and I'm going to kind of refer to this as the circle method, that if you're trying to put one into the other, if you're trying to turn one into the other form, you're always kind of starting here and then circling around this way to make your numbers line up correctly. Okay, so as an example for you, we know that 2 to the third power equals 8. That means I could also write this as log base 2 of 8. And if I ask you that question, what is log base 2 of 8? Really the question I'm asking you is, what is this exponent? What exponent turns a 2 into an 8? And so you would tell me that it's 3. This is what this would look like in numerical form. Okay? Okay, so quick definition here for you. A common log is a logarithm with a base of 10. So anytime we can make a log have any base that we want. This number down here can be anything we want, but when it has a base of 10, that gets its own special name. That's called a common logarithm. Okay, and the reason we like common logarithms is these are the logs that can be found in your calculator. So in your calculator, you have a log button. And that log button really represents a common log. So that's a log base 10. Okay? So again, just to demonstrate for you. Also, I should say, when we do common logs, we don't write the base. All right? So kind of like when we did square roots, we assumed that if there was no number there, it was really a 2. If you have just an x, we assume there's a 1 in front of it. If I just write to you log of 100, for example, and there's no base written down here, we assume that this is a 10. And notice what this question is really asking is what power does it take to turn a 10 into a 100? Okay? Hopefully you can answer that on your own, but if you're not sure, in your calculator, you can type log of 100, and lo and behold, answer should be 2, because 10 to the second power makes 100. Okay? So when you type log of another number into your calculator, if you type log of, I don't know, 54, the question you're really asking is 10 to what power makes 54? Okay? And so you get this 1.73. If you do 10 to that power, okay, 10 to the power of that 1.73 number should come out to be 54. Yep, there you go. Okay? So that's what logarithms are all about, is asking you what exponent does it take to turn this number into this number. So we're going to get more into those types of questions in just a minute. For this first example, we're just going to try rewriting these things from one form to the other. So we're just going to go back and forth between log form and exponential form. So like with this first one, 3 to the 4th equals 81. Remember, I'm starting here and working my way around this way. So this would look like this, log, sorry, there's kind of a crazy shadow going on today, base 3 of 81, and then the answer is always the exponent. Log base 3 of 81 equals 4. When I say 3 to the power of x equals 27, that's log base 3 of 27 equals x. Okay, log base 3 of 27 equals x. Why don't you stop for a second and try that third one? Should be log base m of k equals p. Just testing to make sure you get everything in the right spot. Okay, always goes this way, m, k, p. Okay. So example 2 is just going back the other way. Example 2 is giving you logarithms and asking you to rewrite it in exponential form. And so like for this one, this would be 4 to the power of 3 equals 64. This is your base and this is your exponent. So 4 to the power of 3 equals 64. Next piece, 2 to the power of 12 equals x. And last one, remember when there's no base written there, we assume there's a 10 there. So we would write this as 10 to the power of x equals 100. Okay, so make sure you've got those down. If you need to, go back and rewatch if you're not sure where I got those numbers from. I'm going to stop this video here, and then I'll pick up the rest of the lesson in a second video just to give you an opportunity to make sure that you have these types of problems really understood before we get into evaluating and all that stuff. Okay? All right, so to be continued.